Redshift is a very powerful petabyte-scale fully management data warehousing services that are very popular among our customers with AWS. A typical query comprises 8 to 9 stages in its full lifecycle, and I'm going to walk you through some system tables that you can leverage to check on the background jobs that are actually happening under your query background. For the stage 1, parsing and validation, what does that mean? Sounds like technical jargon, but Redshift parser is just a SQL engine that's doing the analysis and sanity check of your data sources. After your data sources pass the validation, it will be moved from parser tree to query tree, and you can query against STV recent system table to check queries on query tree state. Redshift also has a cache that if it identifies your query results in the cache, your leader node will fetch that and send back to clients. You can check SVL QLog system table to check the history of your query. Next stage is the query logs. So your query need to acquire logs to have committed resources. This stage is a very important system table equal STV logs that you can query against and to understand if you have any undesirable processes holding logs, which you can check the attributes called grants. If that shows T, which means true, then that means that your processes are actually having the desired and necessary resources and it's actually being granted logs. Next stage is Planner and Optimizer, which is a very powerful feature for Redshift. That Redshift Optimizer is a very intelligent services. It will rewrite your queries to make sure that you are making the best use of Redshift design. So basically, Redshift is a distributed data warehousing. So we highly recommend you query STL explain system table regularly to check if there are any costs like incurred during some several steps in your whole query lifecycle that actually is very expensive processes. For example, like hash join or broadcast inner table or broadcast outer table, those you might think about fine-tuning your query a little bit more. You can search for Redshift query best practices to have a comprehensive instructions on that. WLN Scheduler. WLN stands for Workflow Management. It is a very powerful configuration that it decides what the queuing and the query processing orders with your Redshift environment. For example, we have seen a lot of like critical queries with our customers that are actually being placed in the default queue. So basically, default queue is the least and last order to being processed. So we highly recommend you can check out WLN configuration with our AWS public documentation to understand it's always best practices to put your ETL queries or jobs in its specified query group and allocate necessary concurrency scaling capacity or query priority to it. You can query against STVWN query queue state for understand the queuing state. For code generator and compiler stage, I want to talk a little bit about segment. Segment is a combination of steps, which steps means like operation processes. For example, like select statement or query temp table. So slice is the most basic unit of computation resources, while a string is a combination of segments. So all the segments in the same string are running in parallel, but after all the segments completed in one string, Redshift move to the next string. System table STB in flights is where you can query against to understand your running scripts, your running queries there. For next stage is distribution, which means leader node distribute the code to the compute node. And for query execution means compute node is going to do the heavy lifting. And for running state queries, we can query against STV execute state to understand what are the queries are actually currently running. For past execution, we can query against SVL query report and SVL query summary. For final computation and aggregation, this means Compute node is sending results to the leader node, and leader node is going to perform this final computation and send result back to clients. If you have commit operations in your DDL commands, it will involve commit queue state, where leader node will wait after the commit operations completed on all the compute nodes and then send result back to clients. You can query against STL query and STL WN query, and also STL commit stats to understand all the background jobs that has been completed.